Hey there, Joel here and welcome to my channel Math World. Today we're going to learn a different type of constructions. We have already learned construction of tangent to a circle. Today we're going to learn how do we construct a similar triangle. When we have already managed to draw one triangle, we have to draw a similar triangle to that. Okay, so let's roll the intro and let's quickly jump into it. Using a pair of compass and a ruler, construct triangle ABC with sides AB is equal to 6.3 cm, BC is equal to 4.8 cm, angle B equals to 60 degrees. Then construct triangle A-BC similar to triangle ABC, whose sides are 4/7 of the corresponding sides of triangle ABC. Now, whenever you are constructing similar triangles, there are two important things that you need to keep in mind. First one is the name of the similar triangle, and second is the ratio. Okay, so we will concentrate about the ratio part a little later, but know that whenever you are talking about the similar triangle, that it has to be in respect to this triangle ABC. And what I mean by this is, all you have to do is remember these vertex. So one is A dash, B is another vertex, and C dash is another vertex, right? And here we have ABC, three vertices over here for the triangle. Now, or vertices you can say. So what we are doing is, we will take that vertex which is common to both these triangles. So over here there is one which is A, this is A dash, so it's not common. I have B and I have B over here. That means this vertex is a common vertex for both these triangles. That's the only thing that you have to remember in the first part. So when I start with my construction, make sure that that common vertex is always on the left hand side. Now you'll ask me, maybe even comment that, is it compulsory? It's not. You can keep that vertex on the right hand side as well, but just so that you don't complicate things, try and keep them on the left hand side, and then you'll be able to solve the construction very easily. So okay, so what I'll do is I'll start by, now once I'm planning to keep my point B or vertex B on this side, now which is that distance will I have to take. So I'll have to probably take, it's better always to take the longer distance on this what to say, why am I missing out words, horizontal line, and the longest one, so 6.3, right? So I'll take that B over here and 6.3 there. Okay, so this will be my point B, which is the common one, and I have taken 6.3, right? So B A. Make sure you always write the measurements immediately. So 6.3 centimeters. Okay, so B A is done. Next, I have to draw an angle 60. I hope you know how to construct angle 60, because this is part of your 9th standard portion. Take some measurement, okay, anything, whatever. It's not compulsory to measure how much is this, and just draw an arc. So what I'll do is I'll draw an arc this way. This is again you don't have to draw it very dark, and then with the same measurement, keep over here where your semicircle was drawn and cut that. So wherever it intersects, and I'll just draw a straight line, okay, and that would make my angle 60 degrees. So since it is 60 degrees and I know how to draw it. I'll just write 60 degrees. You can measure and verify if you want to. Okay, so A is over here, B is over here. Now this point somewhere on this line will be my point C. So how much should I take? If I take BC as 4.8 centimeters, I know where exactly it would be. So 4.8 is here. Okay, so I'm done with this triangle, which is ABC. Okay, ABC, and this will be my 4.8 centimeters. Okay, now all these three things are done. I've used this information. Now next part is over here. The ratio that I have is 4/7. Okay, now remember that if, okay, numerator is small, okay, to what? To the denominator, then the triangle, similar triangle will be inside. Okay, so what I mean over here is, whatever triangle that you have drawn, if the numerator is smaller than the denominator, this similar triangle will always be inside this. Okay, and if the numerator is greater, then the triangle will be outside. Okay, so smaller than numerator, imagine like this: numerator is small, triangle is inside; numerator is big, triangle is outside. Alright, please ignore the raindrop sound because raindrops are falling on my head. No, I don't know the lyrics here. Okay, let's focus. So let's now go ahead. What we have to do is, we need to draw an acute angle, or just draw a line, make an acute angle. So need not be measured, just draw whatever you can. Okay, however big you want, you can just draw it, so no worries. Then what I have to do is, based on this ratio, whichever the number is greater, right? So I have 4 and 7, so 7 is greater. All I will do is mark 7 arcs. Okay, now again, need not be measured, but if at all you take it like around 1.5 centimeters is a very safe distance to draw an arc. But you can take 2 centimeters, 3 centimeters, whatever you want. But imagine 3 centimeters, if you take as one arc, I need to draw 7 of those. So the page might be insufficient. So just draw a reasonable sized arcs. So 1, then 2, then keep them properly, 3, 4, 5, 6, and 7. Now this is what happens. So you can draw a safe and long line so that you don't have to rejoin it. Okay, so now I've got 7 points. Now what I will do is, I will name them. Since my vertex over here is B, I'll name this as B1, B2, 3, B4, B5, B6 and B7. Okay, then since my triangle numerator is small, triangle is inside, right? So all I will do is join this point of this triangle to that A or B7, the last point. Okay, simple. All I have done is drawn 7 arcs and then just join this point to B7. Now I need to draw a line parallel to this line. So a line parallel to this one would be somewhat like this. So these two lines would be parallel lines, right? Now how to draw a parallel line? Very simple. Okay, but first let us understand from where should I draw. Should I draw it from here, 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 where? So it will be based on what is the ratio. My ratio is 4/7, right? So one line starts from 7, the other line should start from 4. Okay, now keeping that in mind, again you can keep the same distance or you can change whatever you want. I prefer keeping it the same. Okay, and then all I will do is from this line I will draw one arc. Okay, now with this same measurement that I have taken over here, I will go to my point 4 and keep my compass and draw another arc. Okay, so one, I've taken this arc and then same I've drawn it over here. Next, what I will do is from where I started this arc, I will keep my compass now and adjust your compass so that you are reaching that point where the other end of the arc just intersected that line. Okay, so over here, this is perfect. Okay, so I have adjusted my compass so that it just touches the end of that arc. So first point I will keep where the arc started, the second one the compass, and I will keep where the arc ended. So now I know a reference. With this information I will keep over here where I started this arc and keep this one where it is intersecting. And then all I have to do is before and this line I will draw where the intersection has happened. I'll draw a line. Okay, now this and this are my parallel lines. Okay, is my construction over? No, we are almost 95% done. Next thing is, all I have to do is, since I have got this as my point, reference point, I will draw another line now parallel to this line. So I have my line over here, that is AC, and I need to draw a parallel line from this point that I've just managed to plot. Okay, so something like this. Now, how to draw? Same procedure. Take some measurement, whatever you want to take it as, and draw an arc. Okay, same way with the same measurement, keep it this new identified point and draw an arc. And don't draw a semicircle, because basically you have a rough idea. If my line is like this, my next parallel line will be almost this way, right? So why draw an arc, like draw a semicircle? So avoid doing that. It just keep the construction neat as possible. Okay, so what I have done, recap, I've just drawn an arc with some measurement, taken that same measurement, drawn another arc over here. Okay, now what I will do is wherever my arc started, I will keep my compass, adjust the size of the compass, okay, in such a way I touch the end of the arc. Okay, so here I started the arc from here and then it ended over here. So I've taken this measurement, and taking that, all I will do is wherever I started the second arc, I will keep it over there and cut this initial arc. So I've got a point of intersection from this previously plotted point, and that point of intersection I'll draw a line. Okay, and this point which I got would be my vertex A dash. Okay, and this point which I managed to get now will be my C dash, and this similar triangle is nothing but A dash, B, C dash. I'm just using a color pen so that you can identify. Please do not use a colored pen or even a blue pen to do or highlight this triangles. Please do not do it. I repeat, please do not use a pen to show all your construction. Okay, this is your similar triangle. To which one? The previous one. Okay, so I'll draw the first triangle. First triangle was here. Just draw a little bit bigger so that you can see it very clearly. Okay, so first triangle was ABC, and the similar triangle is A dash B C dash. And I hope you know what is the meaning of similar triangles. If you don't, then I guess you need to check out the lesson on triangles. I will put the link in the description box and maybe probably over here at the I button. Okay, so go check those videos, learn triangles chapter, and it is usually a part of your August examination, so you need to learn it, and then you will be able to understand what is the meaning of similar triangles. Alright, so two things to keep in mind. One is the name, the vertex that you have to start from, and the ratio. If the the numerator is small, triangle is inside. If the numerator is bigger, triangle will be outside. Right, let's practice another problem, but this time I'll be a bit quick since it was the first problem. I was explaining it very slowly, but this one will do a little bit in fast forward. Okay, so let's start. Using a pair of compass and a ruler, construct triangle PQR with sides PQ is equal to 5.4, QR is equal to 8, PR is equal to 6.6. Then construct triangle PQR dash to triangle PQR whose sides are in a ratio of 3/5 to the corresponding sides. Okay, 1 second, just correct myself. It is PQ dash R dash. Okay, so in this case I told you two things are very important. One is the name of the similar triangle and the ratio. Okay, so if you look at these two triangles, would you be able to comment down below? You can pause the video right now and write which vertex should be on the left hand side. Come on, go ahead, pause it and do it. Okay, I hope you have done that. So what you have to do is, it is PQ dash R dash, right? So with these two triangles, the common vertex that is same for this triangle and this triangle is P. So I will start with my initial construction with this point over here as P. So I will take that measurement which is the greatest and start, and also make sure that P is part of that measurement. So here it is PR, right? So 6.6. Since the sides are in ratio of 3/5, the greater number that is there, I will draw an acute angle. Okay, and then I will mark them in 5 parts. So whatever measurement you want, you can take on the compass. Okay, I told you preferably 1.5 and all is a decent one. You can choose whatever you want. So I will take 1, 2, 3, 4, 5. Okay, so I will name them as P1, P2, P3, P4 and P5. Okay, and now what I have to do is, the numerator is small, then the triangle will be inside. So I have to join this point to P5. Okay, now my similar triangle will be starting from, my parallel line will be from point P3. Okay, there will be something like this. So how do I start? Take your compass with whatever measurement you had marked. You can take the same one, draw an arc, and next will be from this point P3. Okay, then keep it where you started the arc. Adjust your compass. I hope this is visible. 1 second. Okay, adjust your compass in such a way that you touch the end of the arc, so starting and the end. Okay, with the same measurement, keep over here and cut an arc and pass a line from point P3 and the point of intersection, and you will get this point. This point will be your R dash. Okay, so let's again put this in fast forward and get a parallel line over here. I hope this part where we learned how to draw or construct similar triangles is clear, and if you did understand, then please don't forget to hit the like button, share the video with your friends and subscribe to the channel. Till then, this is Joel saying bye to you. Peace, and talk to you guys in the next one. Bye bye.